So last time we did a reporting parameter exercise with curtain panels where I was talking about how we could go in and make good accurate reporting parameters that would actually measure the correct length from point to point in the curtain panel rather than just report from here to here in a sort of horizontal fashion. I want to also show you how to go about doing an accurate angular measurement in a similar way, so you can sort of control for the deformation of the panel. So this is going to use the now legendary 3-point invisible work plane hack. So I'm going to go back into my reference line tool and turn on 3D snapping, and I'm going to snap to the midpoint of each one of these lines. You can sort of do this at any old place, but and you're actually going to make something that's going to look a little redundant and weird, but you're also going to connect all three of these points into a triangle so that when you hover over, you're going to select all three of them. And then you're going to go create form. And what I like to do is, we're going to end up using this plane as a sort of as an invisible work plane. So I like to go in and set it up as a new material that I usually call gone. You can call it whatever you want, invisible. And I just make it mostly transparent, and I favor the yellow. And so it's going to sort of show up there as a sort of semi-transparent thing. Also make sure that it isn't visible. So now that's not going to show up in my project. But what it is going to give me is a work plane upon which I can dimension. So I'm going to get this one back out of the way. And I'm going to add an angular dimension to this. And I want to make sure that I'm on that work plane. So now if I go and I select this line and this line, I get an angle. Now, it seems a little silly at first to go through all this trouble to get an angular dimension. However, wrong direction here. However, you'll see that what happens if you don't go through that trouble is you don't really have an accurate way to hang that dimension. So say I am on the active work plane level 1, which would be the default when you would open up one of these families, and you just jump right in and start getting your dimensions. Or actually, better yet, I can even show you over here. If I just go and get my dimensions on the same thing, both 90 degrees, right? No problem. Looks great. Well, if this thing in your project starts to go out of plane, or it gets deformed, these are not reading out the same thing. 90 degrees is the projection of that angle down onto a flat work plane. But the real angle is this one, which is getting formed as this thing gets yanked higher up. It becomes a more and more acute angle. So you can yank it way up and you start to sort of see what happens to that geometry. So that's why you need to have that triangular work plane here, is to control for that. You know, there's other ways that you can also fool yourself into thinking that you could go in and set the work plane to that. Say you've got 1 out of 2. Well, it still gives you funny numbers. What's that giving me a dimension to? To that, which is nothing particularly useful, at least not in most instances. So what you really need to do is you need to normalize what it is that you're measuring to, and for that you need to have this 3-point invisible work plane hack working for you. Anyway, hope that was useful and comprehensible, because this stuff gets pretty screwy pretty fast.